The side effects of caloric restriction are way worse than any side effects you could possibly imagine from rapamycin.
So which life extension techniques do you think complement one another?
I think the question in general, what would the effect on lifespan be if we started combining different interventions that are known to increase lifespan in mice is a really important one. The one blood test I'm kind of enthusiastic about, we don't have a lot of data yet, but the data I've seen, make me pretty optimistic that this may be a useful test for assessing which people might benefit particularly from rapamycin and efficacy of rapamycin.
How much rapamycin a week is too high?
It's probably going to depend on what your goal is. My name is Matt Caberly, and welcome to the Optispan YouTube channel. Hey everyone, welcome to the Optispan podcast. Today on the R Files, we are going to do a special episode of sort of Ask Me Anything, where we've collected questions from the YouTube channel that people have posted. And Nick is going to hit me with them, and we'll just see where this goes. So it's great to have you back, Nick. How's the Opti baby doing?
She's good. I'm tired, but that's what it is.
Yeah, I know this isn't your first rodeo here, but I think every child is different, and in some ways, I would suggest that having a baby that makes you tired at first makes for an easier ride later on. The ones that are the perfect babies for the first year tend to be the ones that are more difficult later in life. So
I'll update you in like 15 years and let you know.
Yeah, that's right. We'll see where we end up. Okay, cool. So anyways, great to have you back. So Nick is going to ask me some questions that he's put together, and I'll do my best to answer them. So take it away.
All right. So some of these were from Tara and myself, and some of them were from the YouTube comments. So the first one is, I've heard it said that rapamycin is just a calorie restriction mimic. Is that true? And would calorie restriction plus rapamycin be redundant, or would it be more?
Yeah, so I think the way I think about caloric restriction and rapamycin is that they are overlapping but distinct. So it's certainly not the case that rapamycin is a complete caloric restriction mimetic. And I think there are some things that rapamycin does that caloric restriction doesn't do. So, I think one thing that's really important to appreciate is that rapamycin from a biochemical perspective is extremely specific. It has one target and one target only, at least as far as we know, and that's mTOR complex 1. Caloric restriction is almost at the far other extreme of the situation in that it is one of the most non-specific interventions you can possibly imagine. Thousands, tens of thousands of chemical reactions are altered by caloric restriction. And so if you were to think of it as sort of like overlapping Venn diagrams, you'd have this huge circle that is the caloric restriction effect, and you'd have this tiny circle that's rapamycin, and they mostly overlap, but not completely. So, I think this makes it complicated to say how much of the effect of rapamycin is just recapitulating caloric restriction, and whether or not you get all of the benefits of caloric restriction from rapamycin or all of the detriments of caloric restriction from rapamycin. You will see people in the literature say that rapamycin and caloric restriction are completely different. That's not true. And in fact, those usually come from studies of gene expression where they look completely different because, again, when you look at the total effect of what caloric restriction does, it's only a tiny bit of it that overlaps with rapamycin. But if you look at it in the context of rapamycin, it's like most of what rapamycin does is in that caloric restriction effect. So overlapping but distinct. Now, what does that mean in terms of longevity if you were to combine them? I think we don't know yet in people, obviously. I don't know if anybody has ever really done this experiment in mice. It's a non-trivial experiment to do because different levels of caloric restriction have different magnitudes of effect, and the optimal level of caloric restriction for longevity is different in different genetic backgrounds. So to really do that experiment properly, what you'd want to do is optimize for caloric restriction, optimize for rapamycin, and then combine them and see what happens. That's just hard to do. So we don't know the answer. I would say the data from the invertebrates supports the idea that caloric restriction and rapamycin are acting through the same pathways. And certainly caloric restriction inhibits mTOR, right? So the main thing that rapamycin does, we know caloric restriction does. But I don't think we know the answer as to whether or not whether rapamycin longevity effects are completely contained in caloric restriction. And this is a long answer, but I think the last thing I would say on this is caloric restriction in the mouse studies, if you optimize the level of caloric restriction, has a much bigger effect than rapamycin. So, something like 60% lifespan extension has been achieved in mice with caloric restriction. The best we've ever done with rapamycin is 30%. I don't know that either of those have been completely optimized, but I would speculate that caloric restriction is more effective at extending lifespan in mice than rapamycin is if you optimize. But I would also suggest that the side effects of caloric restriction are way worse than any side effects you could possibly imagine from rapamycin, at least at the doses that extend lifespan. So I think because caloric restriction is such a broad intervention in terms of all of the things that it changes, it can potentially have larger benefits, but also is much more risky from a side effect perspective.
Yeah, that makes sense. All right. Well, so the next question is, in the NIH ITP studies, was there a difference in cancer and mortality rates between the controls and rapamycin cohorts?
Yeah, so my recollection of these studies is that when they looked at tumor burden in the mice that had gotten rapamycin, the mice treated with rapamycin had the same tumor burden at death. So again, these were studies that were done where they waited until the animals died naturally in the lab and then looked at the tumors in those animals. And I think that the tumor burden was comparable, but of course those mice died, 30% later than the mice that didn't get rapamycin. So I think the safest interpretation of that is that rapamycin in mice delays cancer progression, but probably certainly doesn't completely prevent cancer. And I think here, given what we just talked about with caloric restriction, this is an interesting comparison because caloric restriction is a very, very potent anti-cancer mechanism, and mice on caloric restriction have dramatically reduced rates of cancer. So CR is a more effective anti-cancer intervention in mice than rapamycin is from that perspective. And I also think it's important to say, you will sometimes hear people make claims like, well, the only reason the caloric restriction or rapamycin extends lifespan in mice is because it prevents cancer. That's hard to disprove, but it's kind of silly to me to make that claim when we also know that both caloric restriction and rapamycin improve function, delay aging in pretty much every tissue and organ where people have looked. So regardless of what the mice are dying from, I don't think you can make the claim that either caloric restriction or rapamycin are only an anti-cancer intervention. They are broadly delaying, in some cases even reversing functional declines that go along with aging.
All right, so my next question. So which life extension techniques do you think complement one another? So for example, do you think TERT and rapamycin would get much greater lifespan extension than either one alone, like in a mice?
Yeah, I think this is a great question. And I think, unfortunately, we just don't have a lot of data. So I think the question in general, what would the effect on lifespan be if we started combining different interventions that are known to increase lifespan in mice is a really important one. There are just very few experiments that have been done. I know Aubrey de Grey is kind of working on this at a small scale with his, what do they call it, robust mouse rejuvenation project, where they're trying to combine different things. I think that's a great project. I think, unfortunately, at least the data I've seen, the controls there appear to be pretty short-lived. So I don't know that we're going to get any convincing answers, unfortunately. But I think we need more of these kinds of experiments where combinations are being tested for lifespan in mice. We just don't have much data. I think what we can say with some level of confidence is that if you combine things in the growth hormone signaling pathway with caloric restriction, you appear to get an partially additive benefit for lifespan. I don't know of any data on rapamycin and telomerase overexpression. The only study I'm aware of was a study from Maria Blasco where they looked at mice that were deficient in telomerase, so their telomeres were getting shorter. And in that case, the rapamycin actually seemed to make things worse. So, and I don't know what the mechanism is there. I don't know if that's been reproduced either, but it's an interesting. So you might speculate that if you combined rapamycin with telomerase overexpression or telomerase activation, you would get an additive effect on lifespan, but I don't have a good enough understanding of the mechanisms to really be able to predict what I would expect that to look like. The last thing I'll say on this is I do sort of feel like there's the possibility that many, maybe all of the interventions we know about today are really acting on the same underlying network. And kind of the way I think about this is, if you think about the hallmarks of aging, those hallmarks are all connected by a network of interacting proteins and metabolites and other factors in the cell. And things like rapamycin or telomerase activation or acarbose or other interventions, I think may all be acting on that same network. And so once you optimize that network, that may be kind of as far as you can push it. And so we may not have optimized that network yet, but I kind of feel like there's the possibility that we're going to hit up against this wall that we just can't do any better. And so that's why I think it's really important for people to begin looking outside of that network. And I've talked before about Aura Biomedical and the Million Molecule Challenge. I think we need strategies like that can step back, not pretend like we completely understand the biology of aging and look outside of what we already know. Otherwise, if I'm right and we are going to hit this wall, we're going to be kind of stuck and we just can't do any better. We need some people using innovative approaches to kind of look outside of that.
Just from what I've seen, it seems like a common longevity sort of stack is metformin plus rapamycin. Would you say those go together? Are they outside that network?
Yeah. So no, I think those two are definitely on the same network. So we know. So metformin. I mean, metformin's complicated because it's got a lot of targets, but the target most people would point towards as one of the important targets from a health span perspective is AMP kinase. And we know there are very, very strong, clear biochemical links between AMP kinase and mTOR. So those two are almost certainly acting in the same network. I think the reason why you hear people talk about combining metformin with rapamycin, there's really two reasons. One is they're both, FDA approved drugs. You can get prescription for them. So it's pretty easy to combine them. And the other is there was a study from the interventions testing program that looked at the combination of metformin plus rapamycin. The take home from that study, it's a little bit complicated because, and it's often, I think, overinterpreted, but the way that experiment was done, they had in the same experiment, mice getting metformin plus rapamycin, mice getting just metformin, and controls. What they didn't have was just rapamycin. And so what they had to do was compare the metformin plus rapamycin to the historical rapamycin experiment at the same dose, which is not the way you typically would want to do these kinds of experiments. And so you have to be a little bit careful about the interpretation. But given that approach, the interpretation was that the metformin plus rapamycin mice did a little bit better than the historical rapamycin only controls. They did much better than metformin alone, but that's because metformin alone doesn't extend lifespan in mice, at least the UM-Het3 mice that the NIH ITP uses. So I think that kind of got overinterpreted as, metformin plus rapamycin is better than rapamycin alone. The other reason to think about using metformin plus rapamycin is that, again, there's at least some concern that rapamycin can cause impaired glucose homeostasis. Again, I don't think that's really much of an issue in people using it off-label, for potential health span effects, but certainly in organ transplant patients, you see, something called pseudo-diabetes. And because metformin's a diabetes drug, metformin might counteract any side effects of rapamycin in terms of glucose homeostasis. So yeah, you hear people talk about it a lot. I'm not aware of any convincing data that, at least to me, makes me believe there's any real additive effect there.
Okay, so I know you personally cycle your rapamycin. What are your reasons for doing so?
Yeah, so I mean, I think there's a couple of things to say about that. One is, and if you watched the episode on supplements that we recently put out, I'm relatively conservative, I guess, in my approach to biohacking and supplements and off-label use of medications. So I was pretty slow to start taking rapamycin. And again, if you watched the episode where I talk about my frozen shoulder, the reason why I started taking rapamycin was because I had a very specific problem that I thought rapamycin might help me with. So number one, I'm somewhat conservative. So cycling to me seems like if there are going to be side effects, you are less likely to have persistent side effects. I guess we should be clear what we mean by cycling. So I typically do about a 12-week course of rapamycin, and then I'll take some time off. And I'm, ridiculously non-scientific in how much time I take off. It varies, and it kind of depends on how I feel. But doing that, you would expect if there are going to be side effects, you're less likely to experience any ongoing side effects. The other reason, though, why I think cycling, may have some value is that in all of the mouse studies, we have learned that between 4 and 12 weeks of treatment is sufficient to give you benefits for a whole bunch of tissues and organs. And in particular, 4 weeks of treatment followed by a 2-week washout, or maybe it's 6 weeks of treatment followed by a 2-week washout is enough to give you a boost in immune function. And we don't know if that washout period is necessary to get that boost in immune function. So if it is, then cycling is a strategy that gives you that sort of washout period where you then might get the benefits. We also know that 4 to 8 weeks is enough to see benefits in heart function, brain function, oral health, ovarian function in female mice. So it's pretty clear that you can get these benefits in a short time period, and there might be some added benefits to giving this washout period where you're not taking rapamycin after the treatment. But the real answer is we don't really know.
This next question comes from a fan on the YouTube channel. So, does 1 milligram twice a week do anything at all, combined with 1 time a week of methotrexate along with Cosentix every 2 weeks, asking for a friend, winky face?
Yeah, okay. I like the winky face. Okay, so I feel like I have to say I'm not a medical doctor. This is not medical advice. This feels like a good time to just reiterate that point. Again, I don't know. I mean, look, everybody's going to be different. So I think we just have to appreciate there is no right answer to this question that is going to apply for everybody. I think for some people, 1 mg twice a week could absolutely have some effects, right? It's going to be very individual dependent, and it's going to depend on what else you're taking. So like in this case, 1 mg twice a week combined with other drugs could have a larger effect on inflammation, for example, than 1 mg twice a week in people who's not taking any other anti-inflammatories or prescription medication. So the answer is I don't know. I'm sorry. I guess what I can say is, there's some data. Michael Polymenis at Texas A&M has published data on some longevity benefits from methotrexate in invertebrates. I don't think there's any data in mice for longevity, but some evidence for health span benefits. So maybe combining methotrexate with rapamycin would have some sort of additive, but again, that's really speculative. Again, not an MD. I don't know of any reason why 6 milligrams of rapamycin once a week, a higher dose of rapamycin once a week, would be problematic with the other drugs that have been mentioned here. And the one thing I will say is I have heard multiple anecdotal reports where people have started taking rapamycin and come off of other medications for chronic pain or for inflammation. So, it might be a case where in an individual situation, taking a higher dose of rapamycin once a week would actually allow a person to cut back on other medications that they're taking. But again, it's going to be very individual dependent.
Yeah, I hope that's helpful. So another listener comment. I've tried to milk all there is for rapamycin scholars like yourself and Peter Attia. Many questions remain, though. I've heard comments like having a canker sore is proof that rapamycin is working. However, I've gone for months without any sores, and on other times I've had sores that go away.
Right. Okay.
On the same weekly dose.
Right. So I think a couple things to say. So the mouth sores, of course, are the most common side effect seen with rapamycin use in organ transplant patients. That came out as the only side effect we saw that was statistically significant in off-label use in our published study. So it's a real side effect of rapamycin. Of course, people not taking rapamycin get canker sores all the time. So even if you're taking rapamycin and you get a mouth sore, it's hard to know with 100% certainty that it's because of the rapamycin. Let's just assume that it is. Here's the way I would think about that. I would suggest that the mouth sores are an indication that the rapamycin is having an effect, that you are in fact inhibiting mTOR sufficiently to induce mouth sores. But I certainly would not assume that because you aren't getting mouth sores that the rapamycin is not having an effect. The mouth sores seem to be very individual dependent, and really I have no understanding why some people get them, some people don't. Some people get them sometimes they don't. So I think the mouth sores are a sign rapamycin at the dose you're using it is working, but absence of mouth sores doesn't mean anything, is the way I would think about that. I would say measuring rapamycin is really something that should start to become standard for people using it off label. I understand why, most people don't do it, why most doctors don't require it. I think if you've got the resources, you should probably get it measured, because I think there is going to be a lot of individual variation in the way that the rapamycin is taken up and the way it's metabolized. And we don't have a lot of information about that. The only way you're going to know is to measure it in yourself. LabCorp has a good sirolimus test. Sirolimus is rapamycin. So there's no barrier to getting it tested, getting your blood levels tested if you want to do that. So, and part of the reason why I say this is we just did this recently here. And once we have a couple of replicates, I'll share it on the channel for my own experience. But, I've been taking 8 mgs once a week, and we measured my rapamycin blood levels at the 1 week time point. So a week since the last dose, 2 hours, 4 hours, and 24 hours. And it was interesting. So I had no detectable levels at 1 week. Some people do, some people don't. So there's some personal variation. By 2 hours, my blood levels were up above 20 nanograms per mil. 2 hours, hour and a half to 2 hours is thought to be the max. But then by 24 hours, it was down to 3 nanograms per mil. So assuming that is reproducible, it seems like I am a very rapid clearer of rapamycin. Some people using it off label have reported half-lives of, 24 hours. Obviously, mine is much shorter than that if I went to 20 to 3 in 24 hours. And then if you look in the organ transplant literature, you'll see numbers like 64 hours. So I just all of that is just to say that I think the only way you're really going to know where you fit is if you actually measure the rapamycin level in your own blood after dosing at a known dose.
So now that you know you're a quick metabolizer, does it make you want to change your timing or your dosage or anything?
Yeah. So a couple things to say. I don't think it makes me want to change my dose. So like I said, I was at 8. I reached a peak of 20. So part of the challenge is we don't know what the therapeutic dose range is. But that peak, I think, is high, certainly higher than at least the few reports I've seen from people using 6 to 10 mgs of rapamycin. So I don't know. Doesn't really make me think I want to change my dose. And in part, it's because, my only experience where I'm confident that I have experienced a positive effect from rapamycin was with my frozen shoulder. And so I'm still in that same dose range. So, I think it probably has efficacy for me in that dose range, at least for chronic inflammation. I also want to repeat it. Like I said, this was only once we did it. So being a scientist, I want to see replication before I, feel too confident that those numbers are accurate. If they are, then yeah, maybe I would think about, going up in dose a little bit. I'd have to think about it a little bit more.
Yeah, we'll find out. So some people test for levels of rapamycin in the blood. Others use blood markers like red blood cells to indicate negative effects. Is there a list of tests that are better indicators of rapamycin's effect?
Yeah, so we just talked about the blood test. Again, LabCorp has a sirolimus test that you can get that will measure rapamycin in the blood. I think that's good to do as we just discussed. So I think it depends on what you're looking for, right? So for side effects, I think there are some obvious blood tests that you can get if you're concerned about things like hyperlipidemia, right? So getting your lipids measured. Or if you're concerned about changes in glucose metabolism, getting, fasting glucose, fasting insulin, calculating insulin sensitivity, things like that. Those are all smart to do if you're going to take rapamycin off label anyways. If you're talking about efficacy, there's just not a lot, unfortunately. We don't have a lot of good blood biomarkers or other biomarkers of efficacy at this point. The one blood test I'm kind of enthusiastic about is called SapirX, and it's from a company called Sapir Bio. So we use this here at Optispan. And it measures, among other things, immune function and immune senescence, or T cell senescence in particular. So we don't have a lot of data yet, but the data I've seen, make me pretty optimistic that this may be a useful test for assessing which people might benefit particularly from rapamycin and efficacy of rapamycin. And so I actually just got done doing an interview with Natalia Mitten, who's the CEO of Sapir Bio, who makes the Sapir X test. And that'll be airing on the channel, here sometime soon. It might even air before this episode. We'll see how it plays out. So, so regardless, I would refer people to that if you want more information on what the Sapir test measures. But that's one that I think may actually have some utility going forward for assessing rapamycin efficacy in blood.
Is there anything we can learn in regards to health span or lifespan from all the people who have taken rapamycin for their organ transplant?
Yeah, this question comes up a lot. Again, that's obviously a very difficult patient population in which to interpret any data that comes out, right? So what I would say is I think the data is unclear, again, because of the patient population, and you can kind of find whatever answer you want to get in the literature, which makes me nervous about trying to draw any strong conclusions. I think if you look at the whole body of literature where people have tried to look at things like, cancer risk, heart disease risk, kidney disease risk, or all-cause mortality in organ transplant patients who are taking, usually they lump all the mTOR inhibitors together, so rapamycin, everolimus, taking mTOR inhibitors versus those who are sort of matched for the type of organ transplanted, but not taking mTOR inhibitors. The things that seem real to me is that people getting rapamycin or other mTOR inhibitors, organ transplant patients getting rapamycin or other mTOR inhibitors, are generally at a reduced risk of cancer, except for immune cancers, which might be a little bit higher. And again, that might fit with the effects of rapamycin as an immunomodulatory agent. So that seems pretty consistent to me. Of course, I think it's really important to recognize that the effects, the dose is obviously different. The timing of the rapamycin delivery, and what I mean by that is weekly versus daily, is very different in that patient population. And I think the effects of even the same dose of rapamycin on mTORC1 and mTORC2 might be different in organ transplant patients taking strong immunosuppressants along with rapamycin. And then given that we were talking about blood levels, I also, and I don't want to overstate this, I'm starting to become convinced that the pharmacokinetics of rapamycin are very different in organ transplant patients than they are in people using rapamycin, once weekly off label. And what I mean by that is I think this very long half-life that's in the literature is probably the true half-life in most people using rapamycin off label is probably much shorter, but I don't have a ton of data to support that. So I think, we'll wait and see, but that's my guess at this point. So all of that is to say that I just think it's really hard to draw any conclusions from organ transplant patients using rapamycin versus those not using rapamycin.
So in the COVID data you presented, how was vaccination status accounted for?
Right. So all of the participants in that study were asked in the survey if they were vaccinated or not. It was almost 90% were vaccinated. So the vast majority of the people who we collected data on were vaccinated. And importantly, there was no difference by group, right? Meaning no difference men versus women, no difference rapamycin users versus non-users. So we didn't consider like number of boosters or brand of vaccine or any of that, but at least for vaccination status, it was matched across the group.
Are there symptoms indicating mTORC2 inhibition as opposed to mTORC1?
Okay, so I think what this question is referring to, this is probably needs a little bit of context. I think what this question is referring to is there's a model that's been presented mostly from data in mice that chronic treatment with rapamycin, even though rapamycin is a specific inhibitor of mTOR complex 1, chronic treatment with rapamycin leads to inhibition of mTOR complex 2. Actually, there are several studies that have seen that. So that's pretty solid. It's probably dose dependent and length of time dependent. You see it in cells in culture, human cells. You see it in whole animals treated at least with high doses of rapamycin. That chronic treatment with rapamycin can lead to what we would consider an off-target effect of inhibiting mTOR complex 2. The model part is that it's the inhibition of mTOR complex 2 that's leading to all of the bad side effects of rapamycin. I think clearly that's not going to turn out to be the case. But some of these side effects of rapamycin, like dysregulated lipids or dysregulated glucose homeostasis, there's some reason to believe that could be due to the off-target effects on mTOR complex 2. So I think what this question is asking is which symptoms in people would be indicative of mTORC2 inhibition. And I think extrapolation from that is that mTORC2 inhibition is bad and we want to avoid it. So I just mentioned some of the symptoms you might think about: dysregulation of lipids, dysregulation of glucose homeostasis. Actually, I don't know of any evidence whether the mouth sores could be attributed to mTORC2 versus mTORC1. My guess is they're mTORC1, but I don't know. So the real answer is probably not. But again, I want to just be a little bit cautious that I think this model has been overly popularized relative to the support for the model. I think it's certainly not yet clear to me how many of the side effects of rapamycin are really due to mTORC2 inhibition. And that's important because there are a lot of people looking for more specific mTORC1 inhibitory rapalogs. The idea being if you could find a derivative of rapamycin that is more specific for mTORC1 and doesn't have this off-target effect, you'd get more of the benefits and fewer side effects. I don't know of any data yet to support that. What I will say is I think it's pretty safe that most of the lifespan benefits probably come from mTORC1 inhibition, at least in the invertebrate models. The other thing that's worth saying, though, is there are these drugs that are what are called ATP competitive inhibitors of mTOR. So they act through a different mechanism than rapamycin. I think I actually went into this a bit in the first episode of the R Files. So this is a completely different class of drugs that inhibits mTOR. And there's no health span or longevity data on those drugs really yet. A little bit from Restore Bio in their human studies, but in animal models, nobody's really studied this. So I think it's actually a really interesting question whether or not these ATP competitive inhibitors, which will inhibit both mTORC1 and mTORC2, confer similar, worse, better longevity or health span benefits than rapamycin. So it's an intriguing model. It's been a little frustrating to me that the people who seem to want to argue for this model don't actually test it. And some of the experiments to test it are pretty obvious, like the one I just suggested. So I'd like to see the model tested so we can actually figure this out.
I'm actually interested. So what's the mechanism? It decreases ATP?
Yeah, so that's a good question. So mTOR is a protein called a kinase. So that's the family of proteins that it acts in. And what kinases do is they add phosphate groups to other proteins. So it's a signaling mechanism. It's a signaling molecule that does this. So a whole bunch of these kinases in the cell. And that phosphorylation event uses ATP. So the way this works, if you think about this, the protein mTOR in the mTOR complex, there's what's called the active site, which is where the actual chemistry of the reaction happens. And so that active site brings together the participants in the chemical reaction, meaning ATP has to get into the active site, and it's like a fold in the protein, and then the target protein that's being phosphorylated has to get there. And what these drugs do is they look sort of like ATP, so they can bind in the active site, and that keeps ATP out. So because mTOR protein is in both mTOR complex 1 and mTOR complex 2, these ATP competitors will inhibit both complexes. Now, they don't all inhibit both complexes equally, but they inhibit both complexes by sort of mimicking the shape of ATP and getting in there and basically blocking the chemical reaction.
How much rapamycin a week is too high?
No idea.
No?
Yeah, really, no idea. Like, I think we don't have enough data on, again, we don't have the biomarkers for efficacy. We don't have enough data on, where does a single dose of rapamycin become toxic? There's the case reports of people who've taken more than 100 milligrams and nothing happened, or they got high triglycerides. So the real answer is I don't know. I think the safe answer is it's going to be individual. And this goes back to variation in uptake of rapamycin, pharmacokinetics, so clearance of rapamycin, other lifestyle and genetic factors that are going to influence the rapamycin efficacy and side effects. So, so I think it's, the honest answer is I don't know. The one thing I will say is, and again, this is a little bit of speculation, but I'm pretty sure it's correct. It's probably going to depend on what your goal is. What I mean by that is, the optimal dose of rapamycin for, autoimmune disease is going to be different than the optimal dose of rapamycin for frozen shoulder is going to be different than the optimal dose of rapamycin for X, Y, and Z, right? And probably, if you just think about it from a tissue or organ perspective, let's assume rapamycin really does slow aging in people. The optimal dose for brain health might be much higher than the optimal dose for liver health or muscle health, right? So I don't think there's going to be any easy answers. So I guess I would say, at this point, what most people are doing seems reasonable to me, which is, going with around this 6 milligrams once per week, where there's some reason to believe that there's efficacy and some reason to believe that the side effects are pretty minimal.
Is there any idea of how many people are out there taking rapamycin for the purpose of longevity?
Yeah, I haven't seen any estimates. I would suggest that it's probably, at least in the United States, more than 10,000 and less than 100,000, but that's a pretty big range. I think it's clearly gone up a lot in the last 5 years. It's interesting. There are some of these companies that do sort of these telehealth models of rapamycin. They might have a reasonable place to start with an estimate, right? If they've got, 15,000 customers, you could probably extrapolate from that to estimate, but I don't really know. Like I said, it's almost certainly more than 10,000 in the US and 3 or 4 times that much around the rest of the world, I'd guess.
Are companies like Pfizer showing interest in off-label use? Given the overwhelming evidence, are insurance companies showing any interest?
That's a good question. Not that I'm aware of. That doesn't mean it's not happening. So I think one thing I would say is I personally would be a little bit cautious not to characterize the evidence as as overwhelming yet. I mean, I think there's some evidence, but I think we're still a long ways from having definitive evidence that rapamycin has health span benefits for most people. I might believe that's true, but certainly we don't have the data to support that. So having said that, I don't think you're going to see a lot of the big players jump in until there's a larger body of evidence. Maybe now that off-label use is becoming more common and we start to collect more data, you'll start to see that. But I think it's still a little bit early. I've said this before. So first of all, I have no financial interest in rapamycin, maybe unfortunately. But I will say, if it turns out that rapamycin really does have as many of the benefits as it seems like it might have in people and in companion animals, there's only a few places in the world that produce rapamycin. So the production of rapamycin is non-trivial. So it still requires batch fermentation. It's not done by organic chemistry. So if somebody wanted to invest in a rapamycin production facility, I think there may be a pretty big supply and demand problem here sometime in the relatively near future. So
you can't make it in a bathtub like people do
I wouldn't.
Yeah.
Get you some Streptomyces hygroscopicus and try to culture it in your home. No, I don't think that's a good idea.
All right. So this last comment from YouTube is this person's wondering, will you run for president and make rapamycin readily available for everyone?
That'll be my platform. Vitamin R for everyone. So first of all, I would never get elected. So I don't think I will be running for president. But I would gladly accept the job of longevity dictator if I could just make the rules. I'd focus on reform of NIH and FDA and healthcare, all of that stuff, and we'd fix these problems. So I don't know what else I want to say about that. So we'd fix this problem. So I mean, I love the question. Should rapamycin, be put in the drinking water? Is probably a little bit premature for that, but who knows? Maybe someday.
All right, Matt. Well, that was all my questions.
Thanks, Nick.
Yeah,
Been
thank you.
fun.
I hope you enjoyed this episode of the R Files. If you have any questions or comments, please leave them below. Also, please subscribe and share with anyone who may find this beneficial. Thank you.